So, we start with the first section. I think it's a chapter 6 in section 1. It's titled Angle Measure. And I'm going to introduce the notion of angle. So, what is an angle? In mathematics, there are numbers, there are functions, there are objects, mathematical entity that we consider, right? An angle is one of them. And the simple answer is that angle is not a number. It's pieces of data, and angle measure is a number. So here is the introduction of an angle. Angle is this information, right? So there is this point there, and there is this arrow, or in mathematics, we call this array. So although it's a finite length like this, it may indicate the infinite ray starting from here going to forever, right? In physical world, it's difficult to understand what forever this means. So in mathematics, we don't connect this space we're thinking about, to the physical world. This is all happening in your mind, right? So except an infinitude is going there. This is called initial side. I just said it, so I'm just going to abbreviate it like this. Initial side, right? This one is not perfectly horizontal to you, right? It doesn't have to be horizontal. It's just an infinite ray with this point of application. And there is this same thing called the terminal side. So the length of these two segments, it's a trick question. Length of this two segment, does that matter? Length of this two segment? There's no length of two segments. It's an infinite ray, right? So that's why there's an arrow there, right? So there's an initial side and terminal side, and they're joined by this point of application. These are things that go into this information. Then angle is not enough from here. There's one more requirement in angle. That's the crux of this one. That's why we mentioned it. Why we're making this angle so complicated, maybe you already know what an angle is. The purpose of this thing is that the first purpose is the geometry, of course. It's geometry. But the second purpose is they use this notion of angle in physical motion. And you see the half of this content of this course's subject, and the content of this course is going into this physical motion. Although it's a physics problem, its mathematical structure is the main content, so that we consider here. So angle is motivation is because of these two applications. So initial side, point of application, and terminal side, and one more is this rotation. So namely, it's just a motion. So rotation will tell you, this is the two different sides. The initial side is here and the terminal side is there. But rotation will specify, actually, if we move this initial side to get to the terminal side in a simple manner, how did it get from here to initial side to the terminal side? That's the motion, just like clock hands, and rotation will represent that. So how are we going to represent the rotation? By using this type of symbol. Initial side was there and pivoting and go into the terminal side there. So this arrow can give us an idea about the motion, right? Not too specific, but it's at least tells something. So rotation is a number, and if you go about this direction, we call it a positive rotation. We go about a different direction, maybe you can go from here to, can you imagine a different way of getting from initial side to the terminal side? Yeah, going around like this. Do you find it's different kind of orientation of a rotation? Right? Then that one is called a negative rotation. They call this rotation counterclockwise. If you haven't seen the clock with the clock hands, this term makes no sense. But hope this clock is a counterclockwise. Clock doesn't go that way, right? This is a clockwise. The blue one is a clockwise. Correct? Yeah. So that's the amount of rotation. Not bad, right? Yes.
So is that a negative
Because it's the direction, it's not because it's longer. It's a good point. Clockwise, right. Clockwise, negative rotation. Counterclockwise, a positive rotation. The reason why I got like this is because of the orientation of the quadrant in an XY plane. Where is your first quadrant? Up here, right? Where is your second quadrant? There. Third quadrant there. What kind of, is it clockwise rotation if you increase that, or counterclockwise rotation? It's counterclockwise rotation. It's because of that. For some reason, they named the quadrant in that order. They wanted to just go by that. So it became like this rotation. Positive rotation is counterclockwise. Okay? All right. So more example of an angle in here. Don't get confused by this one. So here's an angle. Initial side and terminal side. Right there. And I go this one right here. It looks like a description of an angle. We have all rotation indicated. I'm sketching another angle. One angle and another angle. Making it look as much as a parallel as the other side. Here's the initial side and here's the terminal side. Looks like these two terminal sides of different angles parallel to each other. And initial side looks like a parallel to each other. Let's say they are actually perfectly parallel to each other. How about this point of application? Are they the same? One is over here and the other one is over there. It's different, right? But if I overlap it, it's very difficult to distinguish these two things, right? So let's say it was actually the same point, but I drawn in different things. So it's actually the overlapping picture. All right, I specify that much. Now, rotation is different. Rotation goes like this. You go one rotation full and go slightly more. All right? You can imagine you go around 10 rotation and then go a little bit more and then end up at exactly the same terminal side. Can you imagine these two angles? So if you look at this motion, do you think the motion is the same or different? Motion is different, right? It wants around more. It's just motion is different. Because of that, we say these two angles are different. So another angle. So I write different angle. They're different. When somebody say, is these two angles are the same? They're different, but you will probably want to say something, right? But they're different. Technically, it's a different angle. So let's finish up that sentence. Can somebody close the door for us, please? Yeah. But we want to describe this weird thing, right? They're quite similar to each other, right? So we invented this term. They're different angle, but coterminal. Does that make sense? Their terminal side is the same. All right? If the angles are the same, then of course they are coterminal, right? But if the two angles are coterminal to each other, is that sufficient to conclude these two are the same angle? Yes or no? You don't know anything about, only thing you know is the two angles are coterminal to each other. Does that necessarily imply that they're the same angles? Here's an example, right? We need more information to say two angles are the same. Not just a location of a terminal side and initial side, right? What information do you need to conclude two angles are the same? Rotation. Rotation must be exactly the same, right? All right. When you're looking at this picture that I showed you, how many angles are described in here? One angle? Two angles? 1.5 angles. So there's no. So two angles described, right? But they are coterminal to each other. Is that correct? Yeah. One is rotation. You got to initial side to terminal side like that through that motion. The other angle is going different motion, right? In geometry, that doesn't matter. But in physical motion, distinguishing this thing turns out to be a great benefit. And developing mathematics to the angle is defined in this generality. It fits in nicely to physical formulation. All right? So we're going to accept this as a mathematical definition of an angle. Make sense? Yes. It just means that their terminal side is equal, but possibly the way it is rotated around to get to that terminal side may be different. All right. So another attempt I'd like to make is that what is an angle? Is this piece of information, initial side, where the terminal side is. Thirdly, and most importantly, how is rotated around to get to the terminal side is a part of the angle, the history of this motion. So if it is different, we treat it as different angle. But the confusion might come from, well, initial side and terminal side are the same anyway, then there's additional terminology for that. Okay? It's confusing. As you go down this much of the gory detail and being picky about different and same and the coterminal, that what about initial side, and that is a natural question. But we're not going to be that picky when you're applying this actually on the motion. What really matters is this rotation part. That's the crux of it. I want you to understand angle as a rotation, not just the width of this two ray. That kind of sums up what you need to pay attention. Angle is not just the width of these two rays, but it is more about rotation. How did it got here from one side to other? The motion. Okay? Now measure is now introduced. That's what you need to understand. So here is a point, and here is initial side to the right. Do you agree this initial side is kind of coincide or parallel to positive x-axis in the xy plane? Orientation, positive x-axis to the right. So if your initial side is in this position, we call the angle is in standard position. Hence, we kind of put all the angle in the same position. Initial side like this, not tilted, standard position. Lots of geometry problem is put it into an xy coordinate system, and you have really the power of algebra. It takes care of a lot of ancient trigonometry problems, simple and powerful algebraic machinery, and that's why they wanted to do it. So initial side is like this, and terminal side is described. This picture I'm drawing in here is not precise and perfect. I have to use your intuition and to describe this relationship between this initial side and the terminal side. So this initial side and terminal side is perfectly one line. Does that precise enough to your mind that it is precisely described? It's not crooked. It is a one perfect straight line they're forming. Okay? And we got there by going around just this much. Clockwise or counterclockwise? Counterclockwise. This angle I'm going to call angle A. All right? What is an A? A is a number? A is not a number. A is not a function. A is this whole data is called A. Any of these pieces of data is different, we say angles are different. But what we really care about is a coterminal or not and things like that, and many times. All right. Now the measure of the angle is denoted like this. Measure of the angle A. A is a number? No, A is not a number, but measure is going to be a number. This particular rotation, clockwise rotation, we get positive or negative? We're going to get positive. And what is the amount? How are we going to use a number to amount of rotation? So I don't know exact historical reason why how they come up with this number, 180. But we're going to decide this is 180. We're going to compare all the other rotation to this 180. It's easy to describe, and we're going to call 180. And there is this unit to this measure, right? Anybody know the unit? Degree. And we use this superscript circle over there to assign a unit. All right, this is different from centimeter. This is different from meter. This is different from inch. This is different from grams. New unit, about new idea, right? This measures what? This is the rotation. Now rotation, that piece of information about that angle is represented by a number, right? So number 180, the magnitude is a number, but angle itself is not. All right, so I'm being picky like this, but often we abuse notation. And we write, here's an angle theta, it's a Greek letter, and which is 180 degree. What they really mean by that is that measure of that angle they're talking about is 180 degree. As long as we agree on the context of the angle is discussed, we don't have to be that picky. We just care about rotation amount, right? Yeah. So that's 180 degree. Now, next one will be initial side here. If initial side is over there, what is this angle called? This angle is in standard position, right? Now I'm going to do this one like this. The word is perpendicular. I didn't think I had trouble to get an agreement from you guys that this is a 180 degree, notion of 180 degree, right? The perpendicularity gets a little trickier, right? You got used to this idea of perpendicularity, but I think it's trickier. So how can somebody attempt to describe this precise location of the terminal side in everyday language? How would you use our intuition? Does everybody understand this perpendicularity? Just right orthogonal direction, that's the 90 degree. Make sense? This angle is described with a measure of angle, rotation, 90 degree. All right. Okay, how about, can you imagine 45 degree? 90 degree, if you half it, is a 45 degree. So how would you go about and describe this 45 degree? Well, so I use this isosceles triangle. You draw on some isosceles triangle and center it, bottom half of the point, exactly in the point of application of this angle. The top vortex, that's the direction. It's one way to describe it. How would you describe the direction of this 45 degree? What's that? Acute angle? Yeah, but it's not precise enough. What ray here is that? What other method should we use to describe the precise direction that is a 45 degree? You can use a triangle again. Can you imagine a triangle like this? We already know that right triangle, this square symbol is universal symbol from 90 degree. So I draw a triangle, it's 90 degree, and there's a 1 centimeter here, and turns out this is a 45 degree and 45 degree. I'm skipping a whole lot just to get to your intuition about the triangle. And maybe you mount here some sort of isosceles right triangle, and that's the direction. Right there. Exactly in half. That's what angle? 45 degree. All right. We can think about it, but constructing, if you have this equipment to draw this thing, how are you going to exactly draw this 45 degree? There's a way, but it first puzzles you, right? Yeah. That's the point of the whole discussion we went through about how do we precisely describe or construct this 45 degree. All right? And so another one is if you are familiar with the line and the slope. What is the slope of this line? Do you know what the slope of this line is in xy plane? It's a slope 1. Okay? Rise and this is a rise part and that's a run, right? So go the run part and rise part over there like that. That ratio is the same one. Then that's a 45 degree. That's another description. Does that make sense? Yeah. Justifying is hard because his reasoning is all chained together. So we can only imagine there's this 45 degree right there. It's right in the middle. I don't know how to draw it, but it's just right there. Things like that. All right. Now it's getting harder. How about 30 degree? 90 degrees right up there. How about 30 degree? Split that right into 3 pieces, right? You can think about it, But again, how am I going to exactly construct it if it is in huge miles of the size? How am I going to exactly point 30 degrees so that if you go 2 miles down there, your error is not bad enough, so you're really good. So how are we going to do that kind of thing? It's actually about my question. How are we going to actually construct this 30 degree? But you certainly can roughly sketch it here. That's roughly 30 degree right there, right? But how do you actually draw that? But we can think about it. That's all I'm asking. Can you think about this 30 degree and that's there? 60 degree, twice that, and things like that. So once you understand 180 degree, you can roughly locate that terminal side whenever I give you some numbers. Okay? So here's your first exercise. So if you decided to stay home and listen to the lecture instead of actually coming to this class, these are the things that you have to write it down. All right, you're actually doing it. So sketch an angle of measure. Sooner or later, we're going to drop all these words once you understand, but specifying in here. What is it? 120 degree in what position? Standard position. Position. All right. Does this question make sense? All right. We have some pieces of angles sketched for you, right? So I'm going to get to 120. So that's your exercise. So I'm pausing. So now I see the many students are not working on this problem, and I decided to begin to explain. First, I look at the 120 degree and be able to break this one into two pieces, 90 degree and 30 degree, right? How on earth could you do that? And that's a mystery. How your brain kind of sorts out information from what you know is, and the joy of to understand what happened there, also a frustrating part. But if it is not the combination of something we have already discussed, then you have to go for and explore yourself, right? And you can do that. So 90 degree plus 30 degrees. So 90 degrees right up there, 30 degrees just this much. So together, that must be the location of 120 degrees. So when the answer does not involve this middle one, right? Just initial side, one rotation symbol, 220 degree, and terminal side. That's the 120 degree. Can you imagine that's the answer? Can you imagine negative 120 degree? Yeah? Going not to that direction, but opposite direction. You have to go 120 degrees. So maybe you can you imagine negative 120, 240 degree? Tricky, right? But maybe first you have to do the positive 240 degree. How would you sketch the positive 240 degree? We're going to just multiply 220 and 120 more, right? You can carefully sketch that angle. All right.